Hello and welcome to part 2 of the 1946 Packard auto radio. We're just getting started here, and I've pulled out my first coupling cap, and I know this is a from where I'm sitting, this is absolutely a useless test, or a worthless test I should say, not useless, worthless, because I know these are bad. But I'm just trying to drive home what the problem is by leaving these capacitors in here. The tubes are supposed to have a negative bias on the grid to keep them under control. This is blocking the 200 plus volts from the previous stage on the anode to the grid. And when these go bad, they become resistors and drive that tube grid to a positive voltage. And it's no longer a capacitor. You know, it's just a resistor at this point in its life. And we've got our old Heathkit, venerable Heathkit unit over here. Right now I've got a good capacitor in there, and I guess you can, the seeing eye tube in this is a little worse for wear, but that's a 0.05 cap, and it measures pretty much dead on the money. Oh, I'll leave it in there for a second. Then if I go over to the leakage setting, it's got to withhold 200 volts. So there's 240, or yeah, there's 240. This is about 110, 175. It says 25 volts on the unit. That's not true. Don't believe the 25 volts on these old Heathkit testers. You need at least 80 to 90 volts to fire a neon lamp. But so don't test your low voltage caps on these. That's a caution. But the old high voltage ones are fine. Okay, now we're going to take the capacitor that I just took out of this unit and clip it in here. Alright, let's go down here. Nothing, absolutely nothing showing on, except down here. This is dead. That's a dead cap, no longer a capacitor. When we look at the leakage, you see that light? It's passing voltage right through it, just like it's a resistor. In fact, I bet if I took my triplet meter, the one that uses a 30 volt battery, I bet the resistance reading, it would show on the ohm meter. Can't do it with one of the modern ohm meters, but you take one of those old triplets that uses a 30 volt battery in the high range for ohms, and you'll be able to see this as a resistor. Okay, so we're going to go on. We're going to change out the caps that I mentioned in the last video, the two coupling caps with a push-pull amp, the capacitor that's across the secondary, the transformer that's supposed to be a 1500 volt cap to suppress the spikes, and the filter caps, which are of course worthless. They're completely gone. I showed you in the last video that they're passing 120 volts. Well, they were passing enough voltage to light a 120 volt lamp. Not the full brilliance, but they did light it. So we won't do that with every one for you, but I just like to bring home the fact that those caps have to be replaced before you do anything else. Otherwise, you're taking a chance on damaging what are becoming very rare tubes. You know, if they were still making vacuum tubes today, no one would care. But once the supply of new old stock or even good used tubes is gone, that's it. These sets are done. Well, what was that all about? It was just a blink on my camera display here. I don't know what happened. That was odd. Okay, I'm going... Oh, it just went... Oh, I know what happened. Getting used to a new camera here. I reached behind the camera to press stop, hit the record button to stop the recording, and I passed my hand in front of the eyepiece. This camera has an LCD screen and it has an eyepiece just like a normal SLR would. This camera has an infrared sensor, and when you pass your hand in front of it, or if you stick your eye up to it, it senses you're looking through the other viewfinder and switches screens. Something else I'll have to get used to on this new camera. Okay, it's very disconcerting and I've said this before, this thing makes no sound when I start a recording. I hit the record button, started talking, and I looked over and the camera was off. The battery had gone flat. Extremely short life on the battery, and there's no way to power this thing externally. I am losing. I was enamored with this camera when I got it, but that is very rapidly going away. No feedback when I start to record, and the battery have a very short life. It's probably why they gave me 3. Good grief. I can't believe they've put all these stupid features like double buttons. You know, they've got controls in 2 places on the camera that are just duplicate controls. And they've taken off the ability to run the camera on a power supply, on a DC supply, external. That's just stupid. Where was I? Oh, alright. Talked about changing coupling capacitors. I found, I originally had said there's 2, there was a 3rd one on the first audio where it goes into the inverter. So we have 2 coupling caps, one here, from the inverter to the power amplifier, and we have another coupling cap here I changed. Those 2 coupling, well, actually 3 coupling caps were here, here, and here. And now this one, and this one. The filter capacitors have been changed. I've got the 20 and a 10 stuffed in the old can. The 10 microfarad cathode bypass cap I placed here rather than trying to put in there. It only handles 16 volts, so I had a nice tiny little 100 volt one here. And then the last 5 microfarad, which is in the power supply here, is in parallel with a 0.1. And I said, well, if I'm changing this 0.1 capacitor, I might as well go ahead and parallel the 8 microfarad, because it'll or 5 microfarad, it'll tuck right down inside of here and won't take up any more room, hardly any more room than was, you know, there before. So I've got those 2 caps here. And for those who don't know, the 0.1 is for RF bypass and the other one's for low frequency filtering. They filter caps, you know, large value ones, have too much inductance to do a good job or an efficient job at RF frequencies, stuff with fast rise time. So they usually parallel a smaller value cap to the RF bypass work. This is the 1600 volt buffer capacitor that buffers the spikes coming out of the transformer. That's this one here. That's brand new. This one is a bypass for the vibrator points to ground, and remember I had expressed some concern these might be paper, so I lifted a leg of this and tested it at about 600 volts and it wasn't leaking. And these are supposed to be good for 1000 volts, and it measures within 5% of its rated value, so that's in good shape. So I think at this point I'm ready to put some power on this and see if we have any sound comes out of it at all. So you get to see if the smoke leaks out right along with me, because you do know these sets operate on high pressure smoke, and the evidence of that is when it leaks out, when there's a bad seal, the unit won't work anymore. So it proves that they run on high pressure smoke. I'm going to hook up a test speaker. I've got a 3 ohm, 3.2 ohm speaker here, permanent magnet speaker. The reason I'm not going to use the car speaker is it's got very short, these leads aren't very long, and the speaker would have to be right in my way when I'm working. Where my test speaker has some leads. I put a Wago connector on here, which will help me, first of all, isolate that 6 volt lead so it doesn't short, and allow me to hook up my test speaker. If you're not familiar with these Vago or Wago or however it's pronounced, it's a German word. These things are absolutely awesome. They have several different styles of these, and they're actually starting to use the other style for house wiring, and I've been converting over to them as I do house wiring. We use these when I was working, and they're fabulous. They just are failure proof. I've never seen one fail. Okay, speaker's hooked up. I've got an antenna plugged in. This little paper, by the way, I just threw the tube numbers on the back side of it, so when I'm working in here and looking at the schematic, you know, I look down at the schematic and I say, okay, well, I'm going to follow my signal to the 7A7. Where's the 7A7? Oh, it's right here. So I know exactly, without having to go on the other side of the set and look. So we'll get this out of the way for the time being. I'll be able to see it, but I'll let you guys see the voltmeter for now. And we'll watch the B plus come up together, and then I can bring this back over. Should turn on the VTVM and let it start warming up. And we'll get our leads over here. Chassis ground. Let me grab a test lead over here. Oops. Bang the camera, son. Put that on the positive probe, and let's see here. We'll pick up the anode at a 7C5s. On my other schematic where I made some notes, it should be around 200 to 215 volts on those anodes. So that's pin 2. Oh, it's hard on these. Where is the key? There it is. 1, 2. Alright. There's pin 2. And I gotta get up, grab the power, turn the power supply on, and get behind the camera here. Okay, power supply is on. Grab my test lead, or mine. I think they'll reach. I hope they'll reach. I don't have any heavy ones that are any longer. Ooh, just made it. Just made it. Okay. Off. Now, I have my test vibrator installed. The one that was in here was absolute junk. It absolutely didn't work. I'll cover that in another video. I tore it down. I took it apart. My sister was here, and I didn't video it. She was out in the garage with me when I did this. But we're going to put a solid state unit inside of here, because this mechanical one is long past its sell-by date. It wouldn't run at all when I took it out, and it didn't matter how hard I banged on the thing and tried to get the reed to vibrate. Sometimes if you hit them hard enough, you get the reed to bounce to the contacts and they'll start up and run. But this had so much corrosion on the tungsten points in there that there was no way it was ever going to run. And they're very eroded. They've almost eroded down to the base metal. So that vibrator is no good. The one I've got in there is not very good, but it's good enough to test the radio with. Alright, DC power's on. My voltmeter's hooked up. Let's see if that smoke leaks out. Now you can hear my vibrator having a hard time. It'll settle down here. There it goes. And we've got what? We've got 210 volts. That's pretty close to 215. That's close enough for the girls I go out with. I'm hearing scratching in the speaker from the volume control. Let's run the tuner up and down and see if we have anything. Absolutely nothing. Alright, I'm going to go grab the signal tracer and let's see what we can find together here. Let me stop the camera and go get the signal tracer. Should have had it over here already. How professional of me. Okay, the old Heathkit signal tracer sitting here on the bench humming away. You can probably hear it quite clearly because it's fairly close to the camera. And I've got my reference sheet back over here so I can see what I'm doing. Okay. We're on RF. The signal tracer is working. And we're going to hear some vibrator hash. That's absolutely normal. All of these sets did that. That's that bzzz you're hearing, 115 hertz buzz you're hearing. Some radios actually had a metal shield over this section. I've seen most of the Delco ones. It was actually a metal shield that covered this part of the radio to just eliminate that last bit of vibrator hash. But when you're in the car, you can't hear this when the car is running. Let's see here. Okay, let's start up here on the first stage, the 7A7, and our anode is pin 2. Our 7A7 is here. Pin 1, pin 2. And let's run this through its tuning range. Oh, look at that.
And need to make a will, as we have nothing in place.
Okay. Turn it up just a little bit.
Child in your will that refuses to have a relationship with you. We aren't quite sure how to handle this. We love her dearly, of course, but also don't want...
Yeah, so the RF stage is working. The RF front end is working. So we've taken the signal here. We've got to go through a 250 picofarad into the coil that tunes our RF amplifier. This is an RF amp. It has a peaking coil, which is part of the tuner. Oh, excuse me. This is the antenna peaking coil over here. That's working. So we're coming out of here. We're going to go through this peaking coil, which is the RF amplifier peaking coil, into the converter. And we should see something on pin... That's pin 6, I believe. Let me look at the other schematic here. Yes, pin 6. So 1, 2, 3, 4, 5, 6. We should have something here. Let's see if I tune it.
Anymore? I don't want to talk to you anymore. I'm assuming that means I don't want your money either.
Okay, so we're making it through. We're making it from the 7A7 through this 250 picofarad cap, through this coil to here. Now the next point I should pick this up is on pin 2 of the 7B8. And this is the 7B8 here, so pin 1, pin 2, right there. Let me get another test lead. If I slip off that, I'm going to have a disaster. Let's see what we got. I'm hearing vibrator hash. Let me turn this down a little bit. I'm not making connection here. Just there it is. Okay, we've got nothing coming out of the converter. Am I on the right pin? 1, 2. 1, 2. Maybe that tube is bad. Is it warm? Oh, it's not even in its socket. Good grief. Another one ready to fall out and roll around. Thank you, Lockable Tubes. Okay, that's seated. Now let's see what we got. Still nothing, huh? Oh, there we go. Oh, that's out of the speaker. That's not out of my signal tracer. That's right out of the speaker. Ow. What did I hit? Oh. I just got bit on the 6 volts because the 6 volts has spikes on it from the vibrator. All of these bypass capacitors aren't working, or the bypass caps probably aren't working. So there's quite a bit of voltage. If you touch this and the chassis, it's like taking a transformer with a 1 volt battery or a 1.5 volt battery and touching it. It'll give you a bite. It's the same thing here. It's not a dangerous shock, but it sure is a shock when you get it. Okay, what was I about to... Oh, I was going to tune this. Let's see here. Stay away from the battery lead. Let's see if I can tune this. These are funny little knobs. Every one of these push buttons has its own little tuning wheel on it. And that's how you set it. And got it again. Alright, I'm going to put a knob on there. There we go. Come on. It's horizontal. Slip on. I took these off because I didn't want them to get broken. I gotta stay away from that guy. I'll put those on later.
I'm loving my...
Yeah, we're almost there.
I never get to the situation, and it's all, I mean, it's been my whole career, but it's heartbreaking.
Okay.
What about you, George?
Now we have a push button set to go. So.
Not having a relationship with, she just said, Dad, that said her first words the other day. I'm like, I cannot imagine one day where she's like, I want nothing to do with you. I would be so heartbroken. I think the will would be the last thing on my mind at that point. Yeah. But it's heartbreaking. But even my son's one of the most amazing young men I know. He's 14, and I asked him recently, I said, hey, as we're going into high school, when you reach age X, I want to take just you and me.
Okay.
Anywhere you want to go in the country.
The set's viable. There's a lot of distortion, which doesn't surprise me because of all the bad capacitors that are in here. But now that I know it works, and if it doesn't work when I get done, I know it's something I did and not a fault that was in the set from the beginning. Everything's working. And it actually sounds, other than the distortion, I think it's going to be pretty good. So I am going to go ahead, recap all of it, and I won't bore you with that entire process. We did the troubleshooting bit together. Find out if any more of these tubes are falling out. I can't believe that tube didn't completely fall out. Alright, it looks like all the tubes in the set are good, so I can return his supply of tubes. I can run a test on these and make sure there aren't any weak ones, but I don't think there's going to be a problem running the ones that are in the set at this time. Let me recap it and we'll come back to you. And one more quick thing.
Just scratching the surface.
You can hear that audio sounds distorted there, but if I listen to it at this stage,
they're the best at taking the stress out of payroll, book.
You're hearing vibrator hash because of all this exposed wiring, but you notice how there's no distortion.
Notch CPAs and enrolled agents around the country for over 20 years.
So as we get on the stages, all of these bad capacitors are contributing to that distortion.
And get connected with it.
Okay, just wanted to show you that. And just a very quick aside here. The felt came in, and we threw that in the laser, and that thing just came out perfect. It just zipped right through it, zipped around with the same settings I use for the plastic stuff, and it's just nice clean edges. I'm much happier with that. The only downside is I opened the fume hood too quick, and it was very obvious that this is real wool felt, because boy, the smell of burning hair was incredible. Should have left the hood closed and let the fan run for a while, but it came out beautifully, so I feel a lot better about that than sticking the plastic one in there. Let's see, that's over here. That's pretty ragged looking. It would have worked, it would have served its purpose, but I just didn't like the way it looked, and I wanted some real felt anyway, so I have it now, and boy oh boy, what a difference. The hole diameter is right. You could tell this one oversized because it melted. This came out perfect. Okay, we're coming up on half an hour here, but I want to stick a couple of talk about a couple of things before we close out this part of the video. Everything has been recapped now, and I've checked and made sure that all of these capacitors are good. They're not paper. The set sat down here playing for about 2 hours. I just let it sit here and play, and I'll turn it on here in a second for you. But I was waiting to see if anything had silver mica disease, and it played for 2 hours straight, absolutely flawless. So I'm pretty comfortable it's going to be okay. Rather than take this apart, the more I looked at it, there is a myriad of these tiny little hairspring springs and little snap clips and tiny little extension springs. This thing is loaded with them. If I take this thing apart and something goes sproing, I'm done. And I don't have any instructions on how to get it back together. So I sprayed some lubricant in here and started working it, and I've got it to the point now where it, even without the buttons installed, you know, the push buttons installed, I can change all the channels and everything works. It all goes into position, and I'm not destroying my thumb. Before I couldn't push some of these in at all, and now they're all working. I've got the knobs, or the buttons, finally figured out how to get these cleaned up. These were a bear. I ended up having to soak them for a couple of hours in Windex, and it still took triple-aught steel wool to get some of the dirt off of these. I don't know what the heck was on them. But we put a little plastic polish on them, and they look okay. They've cleaned up nicely, so they're going to be fine. I have the the shadow mask, I guess you could call it, the back. It's painted flat black again, like it should be, so it won't be reflective. It'll be invisible behind the glass. This is cleaned up, so it's looking pretty good. We have our brand new felt piece that'll go over the knobs. That's ready to rock and roll. I'm going to take this outside and I'm going to spray it down with cleaner. I'll give it another lube, work it some more, spray it down with cleaner again, and give it a final lube. But I think this thing's pretty much ready to rock and roll at this point. It's working pretty smoothly. We still have to do an alignment. The alignment hasn't been done, so I'm going to go through and check. It's got a 265 kilohertz IF, and one of my videos I was saying I had to look at the schematic and see if the IF was 455 or 456, and got a note from somebody that said they're all 455, and I said no, they're not. I'm sorry, they are not. I've seen IFs from 50 kilohertz, 100 kilohertz, 150 kilohertz, all the way up into the megahertz region. The only thing I've never seen for an IF is 500 kilohertz, because that was a marine distress channel. 500 kilohertz. Those huge shore stations that used to communicate with the ships at seas used 500 kilohertz. And I think the last one of those went out of service sometime in the early 70s. It was incredible how long they stayed on the air. But at any rate, we got to do the IF alignment. We'll do an RF alignment. But yeah, the power supply's on. While I was working on it, I hooked up this speaker. And this is a speaker I bought when I was working on Tom's. I think it was a 47 Chevy. And I couldn't use it on his set because it wouldn't fit in this opening. However, it does fit in this one. While I was playing with the set and listening to it, I tried hooking up the original speaker, which is this one, and it played. It sounded, compared to the one that this one here, the oval one, it sounded flat. It didn't have any clarity. It just sounded flat. And then the whole voice coil literally ripped out of the center of the cone. It just disconnected itself from the cone. That's how dry and brittle this paper is. So I've glued it back together, and then I gave it a coat of paint and let that dry, and then I gave it a coat of water seal. And the paper now is pretty strong. And the cone, the voice coil is not rubbing. That's the one positive thing that came out of the voice coil ripping itself out of the cone, is the spider was able to center it. And there's no longer any drag, but it's very flat sounding. And no, it's not the spray I put on there. It sounded horrible beforehand. I think I'm going to make a 3D print a frame for this and adapt it into the cover, because he'll have a much better sounding radio. If I can get this to fit in here, it will sound fantastic. So let me turn it on, and you'll listen to my vibrator go through its little song and dance. There we go. It's settled down.
Which I've always supported.
Okay.
But she's working for her mom now as a 1099 with a travel agent company.
Okay.
I bring home
Now, bear in
anywhere
mind,
around
this is not in
$3,500 to
its cabinet.
$4,500 per paycheck take home.
How many paychecks
And
too?
she went.
Let's see if I can find any music.
Great
Probably
WKXL
not.
listeners. Now, last night, as I mentioned,
Can't hear it. Go ahead, no antenna down here.
Which is fine.
All right, that's
you know,
that
I-
speaker.
10,500 between the two of you?
Now I'm going to
Yes,
disconnect
ma'am, that
that.
sounds about right.
Okay.
So I pick up overtime where I can. I take work.
That's disconnected, and we'll hook up. I put some extension leads on the original speaker so I could work with it. So that's voice coil on one side, voice coil on the other side. You're going to hear a little bit of sound because there's residual magnetism in the coil.
She doesn't contribute to it right
There we
now,
go.
just with her 1099 being lower. It's a newer company for her mom, so eventually it'll bump up and she'll contribute. So
Well,
we were
she
wondering
can't-
whether to.
It's with her old job, right?
I'm sorry. It's with her old job. So we didn't know whether to knock out debt with that or roll it over into a Roth.
Yeah, you
I
need
know
to do
what she
it.
wants to do, and
I don't know. Maybe that sounds all right. I just think that the oval one has a much better tone quality to it. Let's pull these back out, and we'll switch back to the oval one here real quick here. And let's see how that sounds in comparison.
Set aside for retirement, that's what it's for. And if you take it, you're taking a hit on retirement funds. And so you would be hit with taxes and penalties because you're taking it before the time period of 59.
I don't know, to my ears that sounds a lot better. I think you'd have a much better sounding radio with this speaker in it. Let me know what you think, and we'll make a decision by the time the next video comes out with what
learn
to do
how
here.
to
Switching to this, I think you'll have a better sounding radio. If I make the adapter plate and I can get it in there, you'll never know what's in there. And he'll lose 2 amps of current draw because he won't have to be feeding that field coil, which draws 2 amps continuously. Okay, the next on the next version here, we'll probably go through the RF alignment and the IF alignment. By then I will have the face put back together. We've got new dial lamps are in already. They're all brand new number 47s in here, so the dial lamp should live for a while. The actual control knobs, he said he has extras, so I'll polish these up as best I can, but a couple of these are pretty far gone. We'll see what they look like when I'm done, but he has more, so you know, they just pull on and push on, pull off and push on, so he'll be able to do that very quickly. Okay, that wraps up this one. I'm the Radio Mechanic. Thanks for stopping by, coming along for the ride. I appreciate it. Always appreciate the comments. Nice to hear from you guys. And we'll take it through the alignment. We'll start working, start closing it up. I've got to clean up the outside of this, squirt some paint on it so that it covers up some of the rust. And then we can get this thing back in a box, hopefully after the end of the next video, and get it back to the owner. He can put it in his 1946 Packard behind that great big shiny chrome grill that's in there. Take care, stay healthy, and we'll see you real soon. Bye-bye.